It's $95 billion. Okay. Why would Google hold $95 billion in cash? As you know, cash is an asset that earns the least. I mean, these days, it's about 4% Fed funds rate. Maybe they can get a little bit higher. Starting October 29th, it's going to be even less. Fed is expected to reduce the interest rates by another quarter. So, as an investor of Google, I could say to myself, how about you pay that money to me? A dividend is company is basically paying its own shareholders, right? I decide what to do with that cash. And Google says, good luck with that, because they have special classes of shares. Even though those two Google guys, Sergey and Larry, technically they own about 10% of Google, but they control all the voting power. So whatever they decide happens to be whatever Google is going to do. But at some point, there's going to be pressure from the investors, and there won't be uh, enough opportunities. Typically, companies hold that kind of cash in case there's an opportunistic acquisition. Let's say, Google is also in the AI stuff right now, right? Suppose they decide to buy AMD. I don't think they will, but and they can simply take that cash, pay the AMD shareholders in cash, and be done with it instead of borrowing money to do all of that. The trouble is, we don't know what those dividends are going to be. Even if we have means to predict them, you know, any means that you use to predict them is a statistical model. Some statistical models are good, some statistical models are bad. But either way, even if you have the best statistical model, you cannot beat the second law of thermodynamics, which is a fancy way of saying uncertainty always increases, or complexity of the systems always increases. This whole discussion actually goes all the way to Plato. Uh, Plato had this layers of realities. There is some perfect reality up there that could never be reached. Then there's an approximation to that in our heads. Then we get ideas from that, and we actually implement them, which is an approximation to an approximation. But those things do not remain the same. There's always new information that comes in. I can make a shoe using that perfect idea of shoe over there. Then I design something in my head, I implement it. But as time passes, you use that shoe. Some things happen to those shoes. So if you try to predict the condition of the shoe 100 years from now, there is a lot more uncertainty about that compared to the condition of the shoe 1 year from now. Because there's going to be a lot more information that comes in, which is entropy. It's a fancy term for that. And that uncertainty always increases. Plato wasn't the one that came up with that explanation. It was actually a 10th and 11th century uh, Islamic scholar called Ibn Sina. In the Western culture, you know him as Avicenna. He's actually the founder of the modern way of thinking about medicine, thinking about in order to prevent diseases, you have to interrupt the vectors of transmission. Before Ibn Sina, you had one kind of disease, and if you got it, you died. That was it. You realize there are different kinds of diseases, and there are different things you need to do. Why do you think the rates of death in uh, what is now Persia has been a lot lower from plague compared to Europe and the Roman Empire in general? because they wash their hands, especially if you're a practicing Muslim, 5 times a day. Before you do your prayers, you have to clean yourself up. Well, if you clean your hands and your face 5 times a day, you are a lot less likely to get something compared to especially middle-aged Europe. You were lucky if you bathed once a year. So entropy always increases, okay? Which means even if I could predict them, there's a trouble with the quality of those forecasts after the near term. So we kind of need ways to operationalize this. We're going to make approximations. This is what all science is. You know, all theories are approximations to reality. Before Newton, we had ways of predicting uh, the orbits of the planets, right? And Kepler's laws of motion. In fact, the stuff they did in Ptolemaic Egypt, it was a very complicated model. I mean, in fact, the model was done to fit the observed patterns, but they could not do much with Mercury, for example. Then comes Newton's laws of motion. He says, okay, if you have this much mass and this much distance between two bodies, I can tell you where Mars is going to be 5 years from today. Okay, beautiful. He had to invent calculus to be able to make those calculations. By the way, you know how old he was when he had to invent calculus? 26. And it was because of a plague. There was a plague outbreak in London. He was in Cambridge University. So in order to get away from that, he goes to the countryside. This is before internet and Netflix, right? So what are you going to do? He starts making calculations about his laws of motion. Then he realizes that he can't make these calculations unless he invented something. He goes ahead and invents calculus, differentiation and integration. That's why, even though I love Einstein to death, I'm sorry, Einstein. You guys call him Einstein. Pound for pound, Newton is probably the smartest person that has ever lived. I mean, there was nothing for him to build on. I mean, Einstein built on a lot of stuff. But that was also an approximation. If you wanted to predict the orbit of Mars, gave you pretty good numbers. Orbit of Earth around Sun, good numbers. Venus, serviceable. But with Mercury, it didn't give you good numbers. I mean, there was a deviation from the orbits predicted by Newton's equations and the actual orbits. Everybody realized that, it's so close to the Earth, it's so close to the Sun, but they didn't know how to do it. I mean, Newton's equations were actually very useful. You guys know that there are 7 days in a week, right? Do you know why there are 7 days in a week? Because in the old days, before Newton, we knew of only 7 wonders. A planet means wanderer in ancient Greek. Okay? The items that wandered on the night sky: the sun, the moon, and the 5 planets other than Earth. Mercury, Venus, Mars, Saturn, and Jupiter. And each of those was assigned a god in the old Greek and Roman times. In fact, our day names, other than Sunday and Monday, are based on those gods. Tuesday is the Norse god Tu. Okay. Wednesday is named after Odin or Woden. It's Odin in Norse, it's Woden in Germanic cultures. So it was Woden's day. So it became, when it came to English, Wednesday. Thursday, you guessed it, it's Thursday. Friday is Frere's Day. Saturday is named after Saturn, of course. If the concept of week had been invented after Newton, the week would have been 9 days. After Newton's laws were published, somebody, and we had telescopes by then, somebody discovers Uranus by accident. Okay. And they said, oh, eighth planet, or in that case, sixth planet. And so, okay, so what are we going to do? They start calculating the orbit of Uranus. It doesn't do exactly what Newton's equations says it should. Instead of saying Newton was wrong, somebody suggested, what if there was another massive planet a little bit outside of Uranus that kind of tugged on that orbit? And when you did the calculations, somebody said, if there was another planet exactly at this location this big, that would have fit Newton's equations. And they published that, an observatory in Germany looks at that location, boom, they find Neptune. So the week would have been 9 days. That wouldn't have been too bad, right? They may have run out of gods to name them after, but